So we're going to move on to the next presentation here. Invite Angel McCoy to join us and to present from BOEM on wind resource analysis. Oh, we're not hearing you, Angel.
There you go. Can you hear me now? All right. I had a double mute on just in case. All right. So good afternoon, everyone. My name is Angel McCoy. I am a meteorologist in the Renewable Energy Program. I'm going to talk about the wind resource and the analysis that takes place to help us in the identification of areas for potential wind energy development. Next slide, please. So in a perfect world, we'd have a thorough network of meteorological stations to collect data at the potential wind turbine hub height. Those exist all throughout the U.S. on land. However, offshore, we rely on mostly buoys that have been deployed as part of the NOAA Data Buoy Center network. And from this data, we would then either extrapolate in order to obtain information about the available wind resource at approximately 100 meters or higher, the potential hub height of wind turbines, or we would rely on model data sets. For example, here I have an image from the National Renewable Energy Laboratory. Walt, I'm sure you recognize the Walt Musial from NREL he presented earlier. And so this is an example of just model data provided by NREL that is freely available and that we mostly turn to in order to get an idea of the available wind resource. And if it hasn't been made clear already, I feel like some of the other presenters did talk on it. Walt did, and I believe Jim Bennett did, talks about, and even Dave McDuffie, talked about how developers, once they've obtained an area for potential development, an leased area, they would then deploy meteorological buoys to collect that more accurate site-specific data at the actual hub height. And that would include information about the wind resource and even the ocean in order to inform the development of their facilities. But in the meantime, as we're earlier on in the process, taking a look at the wind resource in order to identify areas for further wind energy or potential wind energy development, we mostly rely on model data. So taking a look at this map, I can tell you that areas with an average wind speed, annual average wind speeds of about 7 meters per second and greater at hub height, they're generally considered to have a suitable wind resource for wind development. And so in our next slide, we'll take a look at some more specific areas to see the differences in the wind resource in the Gulf of Mexico. Now, starting with the Western Gulf, I'm going to make a little disclaimer here. When I was working in doing this development, just for my own purposes, I called it Western Gulf, Central Gulf, Eastern Gulf, you'll see. But this is not as defined by BOEM. So let's look at the term loosely when I say Western Gulf. But here, starting with the Western Gulf, this buoy is located, this is one of those National Data Buoy Center Network buoys, and it's located just offshore of Corpus Christi, a little over 5 statute miles offshore in waters that are about 19.2 meters deep. Now, if you remember the previous slide, this is an area in the water where the hub height wind speeds are expected to be around that 9 meters per second range, right around 9 meters per second. So there's definitely sufficient wind resource there. And as we look at this wind rose, it's showing us the direction of wind speeds. The frequency of direction of wind speeds, but I don't want you to put much weight in the value of the wind speeds as noted here. Because this is coming from a buoy, the speeds that are measured are about 3.4 meters from the sea surface, or about 10 feet from the sea surface. So that doesn't necessarily correspond with the wind speeds we would see at the hub height of a wind turbine. But this is good for helping us to understand just the direction of the winds that they're traveling and that they're coming from. So here we see that 210 degrees, or the southwest, is the dominant wind direction. And when we look at this wind rose, we can draw some conclusions about the potential shape of a wind energy area, the turbine orientation, and the potential placement of future wind facilities, whether they're upwind or downwind of an area. So keep those things in mind as we progress. Next slide, please. Now, looking at just one wind rose to represent the entire year is not sufficient for understanding the whole wind resource story. And so I broke it up by month, especially since we need to consider that we're in the Gulf of Mexico, where there is a very active and defined hurricane season. And just taking a closer look at these first 6 months of the year, we can see that January and February are most notable here because the wind direction does a significant shift. In the previous slide, you saw that the winds most frequently occur from the southwest at about 210 degrees from that direction. And you can see here in January and February that there is an increase in wind speeds. Again, keeping in mind that this is closer to the surface, but there's an increase in wind speeds that occur from the now northwest. And next slide, please. And here's another look at the latter half of the year, where we continue to see the more frequent winds coming from the southwest in July and August. Some shift taking place as we get into those cooler months. December, somewhat surprisingly, returns to that south-southwest predominant direction for wind flow. Next slide, please. So now we're going to move a little further east. Again, please note that when I say Central Gulf here, it doesn't necessarily mean the Central Gulf as identified by BOEM's planning areas. But this area is just offshore of Galveston, Texas, about 22 nautical miles east of Galveston, Texas. And the water depths here are about 17 meters. And again, thinking back a few slides, here we see that the hub height wind speeds are in that 8 meter per second range. And the dominant wind direction here covers a wider swath than what we saw closer to that Corpus Christi, Texas area. Here we're looking at wind flows from 120 to 180 degrees. And it covers a much wider area there. Next slide, please. And as with the area offshore Corpus Christi, we do see a decrease in wind speeds during the winter months. You see that January and February area, there is a decrease in wind speeds during that time frame, which is very opposite of the Atlantic, I should note, specifically offshore New England. In New England, during the winter months, we see a significant increase in wind speeds there. And that has a lot to do with the occurrence of nor'easters. You may be familiar with them in the Gulf, but it's an extratropical cyclone event. So we could experience near hurricane force winds, but occurring outside of the tropical zone for the Northeast, for the North Atlantic. Next slide, please. So we can take a look at the second half of the year.
We'll do it. And Angela, it's Eric. I just want to let you know you're getting close to the 10 minutes. So if you could think about just wrapping up in an efficient way while covering information.
No problem. So then let's go ahead to the next slide then. And here we're just going to take a look at more of the Eastern Gulf. This area is located 44 nautical miles southeast of Mobile, Alabama, about 15 statute miles offshore to its nearest point. Waters here are about 23.5 meters deep, and the wind speeds are in the range of about 7 meters per second. So we're just meeting that threshold for a sufficient wind resource for the development. And you see here that there's a much wider spread of the wind direction in this area. So it appears that this would be more, you could say, more conducive towards the development of offshore wind because there's more options, more variety available to us for the placement of these facilities and their orientation. Next slide, please. And here's a breakdown month by month. As you can see, the frequency of winds change a direction throughout the year. We're at one more slide, please. And I'd like to take note, again, I always want to reiterate the fact that, you know, these are surface winds because we're looking at buoy data, but we'll see that the higher wind speeds that occur most frequently take place, they're coming from the east and from the north. In the prior slide, in those early winter months, we see a higher frequency of higher wind speeds coming from the north. And then as we move into September, again, we have higher wind speeds coming from the east. And again, we see that occurring in November and December, as I stated before, going into those winter months. Next slide, please. Walter Musial from NREL, he touched on extreme conditions some, and here I believe it's important to give some consideration to the wind speeds that influence facility design and the standards that could be adopted in designing of the facility. I mentioned before that developers would install meteorological buoys to collect some site-specific data, both meteorological and oceanographic information. And in order to ensure the appropriate level of safety and reliability, we look at the site-specific conditions, and then we take this data and enter it into different engineering calculations to, quote unquote, define the normal design conditions and the extreme conditions. So extreme conditions would include changes in wind speed and direction during storms, consideration of turbulence and gusts. And here I've included some of the recurrence periods that are used to define these different operating conditions and as well as to check for robustness and, for example, an extreme gust. Next slide. So furthermore, the site-specific data helps to inform the array and layout considerations. And I have to note here that the wind resource alone does not define the layouts or the array design of a facility. It does have to do with influences from the sea bottom, other uses of the marine space, and other considerations of the users. But when if looking at it from strictly a wind resource availability, we would take a look at perhaps the wake effect, not only from downwind from a facility itself, but even within a wind turbine array. And so those all play a role in how the facility would be designed. Next slide, please. And I'm zooming back in on our different different areas of focus and of consideration here. Again, taking a look first at Corpus Christi. I keep wanting to call it Crispy, forgive me. Looking at Corpus Christi in the Western Gulf, we could conclude that perhaps wind energy area there would be more narrow in design with the quote-unquote front row of turbines facing that 210 degrees or facing the southwestern direction. Spacing between the turbine columns may be noticeably closer than those turbines downwind within the facility. When we take a look at the area offshore of Galveston, Texas, there's room for a wider facility layout with the front row facing the southeast. And I wouldn't be too surprised if turbines in an area near there would be more equidistant, both column-wise and row-wise. And last but not least, looking at the area offshore Mobile, Alabama, there's some more flexibility in layout here. And based upon the frequency of higher wind speeds, again, coming from the east and the north, I would lean towards more facilities facing that east, that front row facing the east or the north. But there's more flexibility in those areas to take advantage of that wind resource and the diversity seen in it. Next slide. And that concludes my presentation. I hopefully sped that up enough for you to get us closer to back on schedule. And if you have any further questions about the wind resource, other freely available data sets, you can feel free to reach out to me, and I can provide more detail and point you towards some studies that BOEM has funded to help us better understand and to better communicate to developers and the broader public on how to take into consideration metallurgical and oceanographic conditions for the development of offshore wind.